Okay, Bismillahirrahmanirrahim. So, welcome back to IIEM. So, today we don't have any Zoom class, but I will explain to you the brief explanation on experiment number 5. So, this is a special experiment that we call operational amplifier, and this experiment is open-ended lab. It's not like your usual experiment. So, this experiment is a bit unique. Okay. So the deadline of this experiment is 2 weeks. So you have 2 weeks to go. So since today and this week you're going to be quarantined in Mahala, right? So you have 2 weeks for you to complete this experiment. So I believe all of you have learned in the class what is about operational amplifier is all about. And for this experiment, you need to do two simulation. So we will introduce you on the PSPI simulation because this is we already conclude the electric circuit parts. So we are moving to the electronic parts. Okay, so you will use PSPIs and also the Tinkercad as usual. Okay, so let's reflect back the learning outcome. So in your EECE 1101, we have 4 learning outcome. Okay, the one that you already done before is KCL, KVL, superposition, and Thevenin's. Okay, Ohm's law we will do after I think next week. Okay, after quarantine day. This is LO number 1, learning outcome number 1, and this 3 learning outcome is from the electronics. So first you're going to have the either experiment or simulation using op-amp, diode, and BJT. And you need to learn to use the PSPICE and also Tinkercad. This is learning outcome number 3. And number 4 is design a circuit. So when say about design, I always mention this inside the class. When say design, you need to find the value of your resistance. So this experiment number 5, is specifically to learning outcome number 4, where you're going to design an op-amp circuit based on the given specification. So this is what we call open-ended lab. Okay, so your report will be due on 20 April before 8 a.m. as usual. And this lab is a special lab we call open-ended lab, and the total marks of this lab is 10%. Unlike with your other experiment, it's only 5% each, but this experiment is 10% of the total marks. So let's reflect back the assessment for the whole course. So you have done this quiz number 1 that consists of 30 marks. You have done experiment number 2, KCL, superposition, and Thevenin, which consists of 5 marks each. And now we move to the open-ended lab that is 10%. Okay. Okay, so what is actually open-ended lab? From the name, open-ended. You are going to predict that you are not given, there will be no procedure given. You need to ask yourself what is op-amp is all about. I believe we have learned this inside the class. Okay, how will the experiment goes? How is the simulation? How are you going to simulate your op-amp? Okay, and then you need to create your own table, your own graph. What will be the input? Let's say this is your op-amp. What will be the output? Is this active or passive device? Do you need any supply? The supply is DC or AC. What will be the input? Is AC or DC? And what will be the output? So you're going to represent all these using a table. Table will not be given because it is called open-ended. You have a graph and you need to analyze this data. Will this data achieve your goal? Let's say you're going to design inverting op-amp. Will it achieve to become inverting and amplified or not? And in your result, you're going to discuss what did you do, the procedure as usual, your observation, are you going to design inverting, summing, or other op-amp? Is it achieve your goal? Let's say this inverting, is it inverted and amplified? And do you have any percentage error? So when we call open-ended lab, you are the one who designed the experiment. You are the one who designed the input. What is the output? What will be the table looks like? And how you are going to analyze the experiment or the simulation. Okay, you are be given a freedom to develop your own experiment. So each of you, we have 25 students here. Each of you will have different type of op-amp, different type of gain, different type of value of resistor, and what will be the graph of the output of the op-amp. Okay, so let's recall back what is op-amp. It's when you have a triangle, so you have how many input? 2 input and only 1 output. One is inverting, another one is non-inverting. Okay, in order for you to design this op-amp, you need to have a feedback. So your feedback need to be at the inverting, and you need to add resistor we call RF. So we have different type of op-amp. One is what we call inverting and another one is non-inverting. For inverting, you're going to plug in your input from the negative input. So this is your V in. Your input need to be in the sine or cosine wave, because you're going to expect your output also will be amplified or inverted, depend on the type of the op-amp. So let's say this is inverting. You're going to add here another resistor, this one to ground, and what will happen at the positive, you're going to ground it. Okay, next, you have learned this inside the class, how you're going to derive the gain. So gain is a very important point inside your op-amp, how you measure that your op-amp is work properly or not. So you have one voltage rule and another one is current rule. Okay, so let's go back to the voltage rule. If here is 0, here will be 0. What will be the current? If the current entering, all the current entering the op-amp will be 0. Next, you are going to derive your voltage gain. Depend on what is the value of R1 and RF that you're going to put here. So this is what we call open-ended lab. Okay, so this is a summary of the op-amp chapter. So please recall back what have you learned inside electronics. So you have different type. One is inverting, non-inverting, and summing. So you can choose either one. It's up to you. This is open-ended lab. So you need to show the derivation, how we can get this formula and this formula. And then after that, you need to simulate the gain. Okay. So this is what type of op-amp. So what is the type of op-amp here? You look at the input. So if the input is at negative, so this is inverting amplifier. So let's recall back, op-amp is an active or passive device. It is an active device. So in order for it to work, you need to supply DC. So in your op-amp, we have 2 DC supply. One is positive and another one is negative. You need to make sure both supplies are connected. It can be only plus, but this one will be disconnected. This op-amp will not work. Okay, so you need to connect this plus to pin number 7, minus to pin number 4. Output is pin number 6, 2, and 3. So what this pin is all about? Op-amp is actually an IC. What is IC? IC is the integrated circuits. So if you see here, we have where is the input? Yes, this is the DC supply, plus and minus, where the plus you are going to connect to pin number 7, minus, let's say this is minus 50, you're going to connect this one to DC supply and this one also to DC supply. Why you need DC supply? To turn on your IC. If you design your inverting amplifier, you need to make sure inverting is connecting to the sine and your output is connecting to the function generator to see whether it is amplified or not. So you are the one who decide you want to design an inverting or non-inverting. Okay, let's go back here. Once you derive, you are going to get here minus RF over R1. So recall back what you have learned in class. So here is 1 plus RF over R1. How you know this one is non-inverting? Your VIN is connecting to the plus. Okay. So since you will use the sine or cosine wave, this is an AC signal. So let's introduce you to the new equipment that we call as function generator. So what is the function of this function generator? Is to generate an AC signal. Doesn't matter it is a sine, a triangular, or a square. So all these are generated by function generator, where you can adjust what? You can adjust the time, the frequency, and also the V peak or V peak to peak. All the parameters related to this AC signal. Okay, and function generator is to generate this sign, but how you're going, there is no display inside the function generator, so you need to use oscilloscope. So what is the keyword of oscilloscope? Is to display the signal. Function generator is to generate this all sine wave. How you ensure that you have create correctly? You are going to connect this one to oscilloscope. Oscilloscope cannot generate this one, it only can display. Okay, so you have two channels. One is the input, another one is the output. Okay, software to use for this experiment. So there are two software. The first one is, as usual, you're going to use Tinkercad, and this is the example of representation of your circuits. So this is an op-amp IC. So you have how many pin here? 8 pin. So your pin, you need to make sure that the pin is connected correctly. Like shown here. Let me open. Yeah, this is the dedicated number for each pin. So you need to follow this one. The semicircle here denote that this is pin number 1. So if you see from your, you can see also the semicircle here. So this is pin number 1, 2, 3, 4, 5, 6, 7, 8. So please denote this pin correctly. So the one that is displayed here is what we call oscilloscope to display. What is the function? To display. The one is showing here is what we call function generator to generate the sine wave or triangular wave, AC signal. Why we need this DC supply? Because your op-amp is an active device. So one is about 4 plus 15. Another one is for another supply that is minus 15. You need to use both for you to complete the circuit. Okay. The next software is PSpice. This is the first time you're going to be introduced to the PSpice. So I already shared with you some tutorials. So please try your best to explore this software. And then this is the simulation that you are going to have inside the PSpice. So this is the triangle. This is what you have op-amp here. Where is the feedback circuit is here. So the one that this brother or sister designing here is actually non-inverting op-amp because your supply is connecting to the plus. Okay. And how you going to display the output? Here is the output. And here is the input. You're going to put your marker at the input and output. And DC supply is connected to pin number 4 and pin number 7. So this pin number 4 is to become minus 15. So you can see minus here. Pin number 7 to the plus 15. Okay. How the table looks like? So this is up to you. This is open-ended lab. Do you need to show the theory? Yes. How you going to represent this result? It's in form of table or graph. You are the one who need to decide. And then you need to calculate the error and discuss. So some related question that can help you to structure your open-ended lab. So you can discuss what is actually op-amp, what are the types, how you calculate the gain, derive, and what is the function of this function generator and oscilloscope, how you increase and decrease the amplifier gain. So use this question as a guideline for you to start your theory and your discussion. Okay. So in order for you to design your op-amp, this is the specification. Your gain must be between 5 to 20. It need to be either in phase or out of phase, and it can be multi-stage or single op-amp. You only can use the list of this resistor because these are the resistors that are available in the lab. Okay, so here is some of the guideline for you to prepare your discussion. So start with the identify and then show the theory analysis, which is the theory calculation, how you get the gain. And then you can combine the resistors either in series or parallel. So let's say this is the list of resistors. So you can choose 3 or 4 resistors and combine it either in series or parallel. And then you simulate your circuits and discuss. and show your result in terms of table or graph. Okay, so how this open-ended will be evaluated? So this 10% of your total marks. So we have what we call rubric assessment for you to assess your lab report. Okay, so first one is the theory knowledge. So how you explain the op-amp, what is the voltage rule, what is the current rule, how you derive the gain, and you draw the circuit of your schematics. So from there, you're going to decide your gain in the range of 50 to 20. Choose one number in between this 5 to 20, and then you derive how you can get the value of the resistor unknown, either it is in series or in parallel. Okay, and then you simulate your design of the op-amp for both. One is PSpice and another is Tinkercad. Okay, so this is the best output, that the highest mark, that is what you call exemplary. So you need to have a detail on the theory and derivation, and then a proper schematics. Either you draw it and then you simulate and show all the labeling correctly in the Tinkercad and also in the PSpice. And then the number 4 is about how you discuss the results, whether you present in terms of table or graph, and then you explain it in detail how this graph looks like. It's either in phase or out of phase. This is a summing amplifier, and then the structure of your reports where it meet the grammatical mistake and so on. Okay, and the total mark of this rubric is 100%. Then it will transform to 10% of the total marks. Again, the deadline of this experiment is on 20 April, so you have 2 weeks. So if you have any question or you stuck in either PSpice or Tinkercad, you can just telegram me and I'll try to help. And again, this report is individual, so this report will be online and individual. So once you are back on 22 April, for section 15 on the Thursday of that week, 29 April. So we will start on the next experiment, that is Ohm's law, I think. Okay, so let me know if you have any problem, and see you next week, inshallah. Assalamualaikum warahmatullahi wabarakatuh.